Thank you, everyone, for joining me today. I'm excited to be part of the NLP Summit on Healthcare. Today, I'm going to be talking about extracting big value from big data in unstructured content. We're going to be talking about a slightly different approach that we have to addressing the copious amounts of unstructured data that we find ourselves in the healthcare world. To give you a little bit of background about who we are as a company first, Vantage is a privately held technology firm based in Bucks County, Pennsylvania. We have offices around the world and operations certainly running in just about every continent except Antarctica at this point in time. We have been leaders in the field of artificial intelligence, big data, and what we call natural language understanding for several decades. Believe it or not, each of you probably use our technology without realizing it, or at least some parts of our technology, in that we have 14 patents in the iOS that allow Siri to talk to you in a natural language way. And if you're not an iPhone or an iPad user and you happen to use Microsoft, the original grammar checker and spell checker that's embedded in Microsoft Office is ours that we license back to them. And I share that with you for two reasons. One, to let you know that we've got a long history of work in the field of natural language understanding and certainly processing of text. And that we are able to scale our operations on an almost infinite level. We touch about 2.2 billion customers a day through all of our various products and different companies that we run. Combined with that, many of you may have actually had some of our AI technologies and text scoring technologies as part of your educational journey, because we've been scoring essays on exams like the GMAT, the Law School Admissions Council test, the Medical College Admissions test, to the tune of about 100 million tests a year. Where we score the essay-based questions just better, faster, and cheaper than humans can do that. We've been doing that for about 2.5 decades at this point. We've had operational projects in this field since 1997, and that gives us a long legacy of both successes and learning from our failures. As you all know, this is not always an easy road, and sometimes you learn as much from the projects that don't go well as you do from the ones that do go well. Healthcare is an area we got into almost by accident. We fell into the healthcare field when we were debating where to take some of the technologies we're going to talk about today. We thought the legal sector would be the right place because of all of the wonderful briefs and filings that lawyers do. And just out of coincidence, we happened to be in a meeting with a good friend of mine who at the time was the dean of an Ivy League medical school, mentioned what we were doing. And she said, "Hey, we have a crushing need for this in the medical area. And can you come help us with that? Can you apply that in our field?" And so just as an offshoot, we started down that pathway. And in that time, we've since grown, as you'll see in a moment, to quite a few different university medical institutions where we apply this AI and technology. And my background is a little bit unique. I'm sort of the newer generation in that I've been doing AI and large-scale text processing, text scoring for well over 2 decades. I got my start actually as a journalist, and I think that helps me because I understand language in a deeper and more meaningful way than most. And then I work with the technologists to really apply that to understanding what is meant by different pieces of text that we look at. So Vantage has been around, as I mentioned, for a little over 2 decades doing this work in the field of medicine. As you see on the left-hand side of the screen here, we work with quite a few different groups who have large corpuses of data that we are able to read, process, understand, dynamically tag, and make sense of. And we do that across a lot of different platforms where we're unifying the data, bringing it together, making sense, because the human brain, as you all know, caps out at a certain point, can only hold so much information. So what we do with our technology is we make meaning from what is essentially an overwhelming amount of data or overwhelming amount of information. And we do that again by unifying data from different and disparate data sources all at once. So in a typical university setting, we might be looking at a patient management system. We might be looking at a library collection of journals and textbooks, and at the same time looking at live lecture capture and the transcripts from those lecture captures, looking also at the all of the handouts, all of the presentation material that they use in continuing medical education, so that we're bringing together sort of a best of content store, not just one content store. And all of the technology you see resides as a layer on top of existing applications. So we're not actually having people rebuild or restore their data in different ways, but our system acts like a librarian who's able to go out, read all of this information and all of these disparate systems, understand what it is, what it means, and bring it back together to bring meaningful data back to the end user. We've done this, as you see here, in at least two of these customer references in different contexts. And we think that's a very important element as well, because while medicine is generally unified across different locations, there is language variety that comes in. And more as we see foreign trained physicians in the US, different sets of notes being taken, different instructors teaching in schools, we're seeing language variety that really needs to be better understood. And our exposure to the global markets gives us that opportunity to figure those elements out. So what was that challenge or the opportunity that was brought to us by the dean? She said, look, Paul, we have this challenge in that we are trying to bring translational research to everything we do. And for those of you who aren't aware, translational research basically means expediting that continuum you see on the right-hand side from basic science research to where it actually impacts the practice of medicine and how it impacts patients. They want to shorten that cycle, obviously in a very meaningful and reliable way. And they want to do it, bring it to a broader audience, because there's so much wonderful information, as we all experienced from the COVID epidemic, where that real basic science research that was happening with the mRNA vaccines was suddenly expedited and brought forward in translation of that research into a practice, so that we could all get our vaccines and continue to engage with society in a more meaningful way than behind these computer screens that we work from. So there was this demand for translational research, and at the same time, there was an identification that a lot of individuals in this era, maybe a decade and a half, 2 decades ago, were generally throwing a search into some of the medical systems that they were using and tending to look for the first 2 or 3 references that would come up. And if they didn't see what they were expecting, they would go out to Wikipedia or out to Google and do a Google search, do a Wikipedia search. And what was happening was they were finding that physicians and researchers were ending up on non-authoritative resources. So this rush, again, to bring medicine to from the bench to the bedside much quicker was then getting challenged, because you were having the issue of less than authoritative information getting pulled in, causing people to really pump the brakes on that push to get translational research into the field of practice. At the same time, these universities recognized that they had unbelievably rich content, because about 2 decades ago, they started moving to content management systems and learning management systems, obviously the evolution of electronic medical records. And they started to build information in a digital format that gave us access now to just this rich breadth of content. And again, not just content in that clinical setting where the practice happened, but research elements from the basic sciences, because of the content management systems where they were publishing drafts of papers. We had learning management systems where authoritative lectures were being given, continuing medical education lectures being given. And they really wanted to make sure we were bringing all of that together. So the first step, obviously, was unifying all of that data and then making it accessible in a way that wasn't overwhelming, because there is just so much content in these systems that oftentimes even the managers of the systems didn't know what they had or how it got there. So how do we do this? Well, we approach this in what we call a neurosynthetic approach. This is literally going back, and for some of you, if you have a psychology background, this may resonate a little bit with you. But what we decided to do was we took an approach much like the human brain. And the example you see here on screen is what we call the reading rope. And this was a model that was generated by a researcher named Dr. Hollis Scarborough, who is a developmental psychologist. And what Scarborough's research said was the human brain, when it reads, doesn't read as a monolithic task. It's not just this one all-encompassing task. It's actually broken down into many different discrete little tasks or threads. And you see those threads on the left-hand side of the screen here. Those threads are what we've done, or what we've built and automated using engineering principles. We've built these various threads that essentially take a discrete task, understand that very discrete element of language, and weave it together. That gets woven together into a bigger thread, and then the next thread gets woven into a bigger thread until ultimately you've developed an engine that is effectively a skilled reader, just like the human brain. In those threads, we see things that are probably pretty familiar to many of you who've worked in the NLP field, things like syntax and semantics. We spent years working on making sure we could understand metaphor and simile when used in a text field. Those are some very complex areas in particular because they used a significantly larger piece of code, and we wanted to be sure that the code we used didn't have a long tail impact on the speed with which we were able to bring results back. And we went a bit deeper with our engines. And we built an engine that actually had phonological awareness. For those of you who aren't aware of this or don't understand this, the human brain was never wired for the printed word, right? So the human brain was actually wired for spoken language. And what we've done in order to improve our engine beyond what a typical machine can do with text is we've built in those elements around phonological awareness, those sight-sound correspondences. The fact that phonemes, the 44 sounds in the English language, have different meaning and change the meaning of words depending on how we use them. And so we've built engines that literally, when they read text, are going to break those elements apart in a text format and understand what phoneme is indicated there, how that phoneme is going to work, and what impact it has on the engine's understanding of the true meaning or the concepts conveyed by the words that the engine has read. So when you think about our engine, this and some of the work we're doing, we've essentially tried to rebuild what the human process is. And again, that's more than just natural language processing, right? Because it's not just simply having an engine that has a concept net behind it that understands the words have multiple meanings and trying to understand it that way. It's not just a linguistic approach that understands that verbs are action words and nouns are things, right? We want to understand this at a much deeper level. So we take all of these different components. We built a series of different engines, and we let an artificial intelligence system essentially weight those and build them back together until the engine has become a skilled reader. We then read all of the content that's published in these disparate systems that the medical centers and the medical universities have, whether they're content management systems, electronic medical record systems, patient management systems, textbooks, journal articles, and we bring all of that together so that when a question is asked or when information is compared, we're able to actually understand it at a much deeper level, a much more meaningful level, because we're understanding it as though the engine was a human. And it says, I know what you wrote, but what I think you meant was, and is able to actually understand that at a much deeper level. So how do we do this? One of the ways is we use deep neural networks. Obviously, all of the rage these days are our large language models with OpenAI and BERT and a variety of other systems. So one of the threads that we pull on as our engine reads is we take two sentences. I suspect pancreatic fibrosis, or it could be fibrocystic disease of the pancreas. And we look to see, we encode these, right, in a very machine readable format. We're looking at vectors and tokens here, and we're understanding those words as a machine would. And we're understanding them in the context that the machine has understood them. We feed those encoded text into the deep neural networks, and then we interpret it whether that was a paraphrase. Did this match this? Did A match B? Did B match C? And so on. So the engine is trained on these accurate and representative data sets. And then our classifier basically says, okay, it's learning this function that you see here on screen so that we can tell whether the input vector is a dimension of the output vector. And we're really starting to match things up. That gets you most of the way there, right? This is, as we've seen from ChatGPT and all the buzz about that, it's good, but it's certainly not good enough in the area of medicine. We've got to get much better. And that's, again, why this neurosynthetic approach of multiple threads gets us deeper and farther and further into this process. So one of the other ways we do this, and I apologize, this isn't a medical example, but I had this one keyed up for you. If you take a sentence like you link a Microsoft Excel spreadsheet to a part file, but the parameters are not displayed, what the engine is doing on a next level is it's actually doing tokenization. And again, this might be familiar to many of you, but we're essentially breaking it into the tokens and with the words and the punctuation signs. We then do a morphological analysis where we look these words up in a morphological dictionary. We do a part of speech tagger. We assign attributes to this and look at the inflected forms so they're connected back to their base forms. Then we take a look at disambiguation, right? We want to clear up some of the areas that aren't quite clear. We then set phrase boundaries because, again, words have meaning, phrases have more meaning, sentences have even more meaning, right? So a phrase is a thought, a sentence is a complete thought. A word is an idea, a phrase is a thought, a sentence is a complete thought. And what we're doing here is essentially identifying these various linguistic components and strengthening another thread in this process so that we can essentially build out or parse this query, much like we did for those of us who are of a certain age. We used to parse sentences when we were learning grammar, and this engine is parsing out these sentences and all of this content, all of this text that the universities and the medical systems have, so that we're able to break these things out and understand them at a deeper level, and ultimately create a normalized sentence or a normalized query. We then start looking at things like roots. We look at preserving phrase boundaries, right? Where we have a concept match conveyed by a phrase. We want to make sure that that gets a higher weighting and a higher value. And we normalize synonyms back to their canonical form. This is something that we certainly spend quite a bit of time on because we find that language continues to evolve. And as we work in a global setting, the use of unique terminology and unique sort of shortcuts continues to grow. We know that there are weaker synonyms and stronger synonyms, and we're checking for language variety again for that Australian English, British English, American English, Singaporean English issue. And ultimately, the sentence, you link a Microsoft Excel spreadsheet to a part file, but the parameters are not displayed where we started, looks to us in this particular thread of that neurosynthetic approach like the red words you see on the screen. Proper pronoun, link, Microsoft Excel, spreadsheet to, part file, parameter, no display. So we know that this is the same as these various questions, right? We're actually matching up sentences that don't look quite the same, don't sound quite the same, but we're starting to marry those up so that we can understand content, retrieve it, so that we can now start to bring ideas and concepts together. When someone is asking a question that may not match exactly what's in the data set, we're able to actually find that and say, like a librarian, we're going to take you to that next level. We're going to find the information that matches up with what we think the engine thinks you were actually looking for. Much like many of you, we also use a concept level understanding. So we've got a pretty robust concept net. One of the funny examples I love to use in the healthcare space is Trendelenburg. At one point in time, my wife was in Trendelenburg, which basically means her feet had to be above her head for 14 weeks during pregnancy. And what we find is Trendelenburg, despite it being a proper name, is spelled differently around a university, around a health system, around the world. So despite this being someone's proper name, you've obviously got to manage the issues of spelling variety, but you've also got to understand that Trendelenburg in some markets and some systems is also described as airplane. So rather than putting a patient in Trendelenburg, I airplane a patient. And that's the same concept where the individual is put with their head down, feet up, essentially like an airplane taking off. We do further concept understanding where we do causes of, treatments for, results of having, and link these concepts together. Because in medicine, the body is a system, and that system isn't taught in discrete elements. It's not learned in discrete elements, and it has effects that bleed over from one area to the other. So we know in this example, glycated hemoglobin is HA1C, which is also hemoglobin A1C, which causes diabetes, which leads to diabetes mellitus. The engine understands that diabetes mellitus, if not treated, leads to neuropathy and potentially retinopathy, which can also lead you to ketoacidosis and ultimately death. So the engine is understanding these concepts that are linked together and how they all fit. What's the result of having this? This technology and this ability to understand language across multiple platforms within a health system? First of all, we're unifying data for the researchers. We're now bringing to light things that they didn't know someone might have been studying in a totally different laboratory, because we're able to actually unify that data and unify it in a linguistic way that makes sense to the different researchers. We're providing both clinicians as well as faculty and researchers with essentially a virtual librarian who knows where everything in their data store is, or any of their data stores, because we've brought all those data stores together. We eliminate the challenge of users going out and finding less than authoritative content, because we're actually bringing them only the authoritative content from the university, from approved resources. And ultimately, it's allowing them to extract considerably greater value from this enterprise of information they've built, but they just don't know how to organize or do anything with it, because they only see it from their myopic, I'm a researcher, I'm going to look at this single data set. Now we're starting to branch that out and look at a much broader, more comprehensive view of medicine in that clinical environment. If you'd like more information on this, I'd be happy to chat with anyone. My contact information is on screen, and look forward to your questions in the chat. Thanks so much, everyone. I appreciate your time.